All right, so I'm just going to show you a quick technique that can be used for kind of creating three-dimensional surfaces based on curves using Grasshopper and Rhino. So what I have here in my top left viewport is just like a sine wave curve, and I'm going to actually go ahead and rotate this so it's vertical here. So what I want to do is make like a couple different curves, and then I'm going to use those to like deform a surface and make them make that surface kind of like wavy, kind of like follow those curves. So let me try this one maybe 80, so down. Okay. And okay, so there's a set of curves, and I'll put those to one side here. And I'm just going to make another curve real quick, and maybe I'll offset this a few times to make kind of like two sets of curves. We'll do some like concentric rings. Okay. So what I need to do is like position these curves in 3 dimensions next to a planar surface. So again, before I put anything into Grasshopper, I'm also going to model a surface here real quick, and that's going to define kind of the overall dimensions. I'll go ahead and do my 7 by 7 here. That was a planar surface. If I go to shaded, you'll be able to see. My curves are way too big. I'm going to go ahead and scale those down so that they're kind of like, I do want them to extend past the limits of my surface, but I also want them to be so big that they're kind of influences not doing what I want it to. So, okay, cool. All right, and then I'm going to go ahead and put all 3 of these bits of information into my Grasshopper script. So I'll go to the geometry dropdown and get a surface, and I'll go ahead and select my planar surface that I made and go to set 1. So I'll show you how to do that in just a second. And then I also want to insert my sets of curves here. So I'm going to go ahead and select that one, those curves. I'll make a curve component, go to set multiple in this case. And then I'll also select all these guys, that surface. Make a copy of this. Again, right click and go to set multiple. Okay. And I can actually hide all this stuff now, just so I'm not away. So I got one set of curves, another set of curves, and a surface. Now what I want to do is divide my surface into a grid of points, and then I'm going to move those points based on their proximity to these curves. So first thing I'll do is go to right-click on the canvas to search for divide surface, and I should get this one. That's just like a grid of points on a surface. I think if you go to the surface tab as well, it'll be under, it'll be that first one under like utilities. All right, so I'll go ahead and plug my surface into that. I can change obviously how many points I have in each direction by setting some sliders here to U and V. The other technique that I sometimes like to use is if I go under my utilities tab and go to, it's in here, dimension, or maybe it's here. Dimensions, analysis dimensions. So this, I can plug a surface into this and it'll like, it'll give me the distance, the size of the surface in the UV. And then I can divide that by an increment. So let's say I wanted like, 2 inches in between. Sorry, let me do that. 2.0 in between each point. Plug that into U. And then, so the U gets divided by 2. That number becomes the number of subdivisions in my U direction. The V gets divided by the same. That becomes my V. And so you can see, like, the larger I make this number, the fewer points, and the smaller I make it, the more points. This number is kind of like how far apart roughly each one of those points is on my surface. Okay, then I need to deform these points based on their based on these curves that I have. So I'm gonna pretty quick. Okay, so I'm gonna use a command called pull. Double click, just type in pull. And I think what I want is pull point to a variety of geometry. I think I want this one, pull point. What I'm pulling is obviously these points here that are my grid of surfaces, my grid of points on my surface. Now you can also see that when I plug that in, I get a dashed line, which means that I have a grafted list. So you can see I have different branches in there. Don't necessarily want that or need that, so I'm going to go ahead and right click on my output of my surface divide and hit flatten. Okay. And then it's going to want a geometry that is pulling on those points, and I'm going to use, that's where I'm going to plug my curves in. So what this will do is it'll tell me, for each one of those points in my original surface, a point along one of these curves that's closest to it. So to visualize that really quickly, I can go to line here, plug in my original points from my original surface, and then plug in my points that are pulled, that I've pulled to those curves. You can kind of see how each one would be moving if I were just to stretch them between where they are and where that surface is. Now there's a couple things I can do with this. I can actually, I could actually just remake my surface right now from those pulled points, and I would get something that's kind of fairly wavy, I think. I can also use this data. So this is telling me, it's not just giving me the pulled point, it's also giving me a distance. Like how far is each point from its closest relative along one of these curves. And so I can use those distances to move the points in the vertical and the z-axis. So I'm going to do that right now, and we can play around with some of these later to kind of see what the different results might be. I'm going to plug in my points to my move. I'm also going to get a unit z vector. That's just a regular generic like vertical line vector. And then right now I'm just going to plug in my distance factor into my unit z to set the length of each of those. And then I'll go ahead and drop that in. You can see it's kind of moving those points up. I'm going to unpreview some of this other stuff. So that might not be that interesting, but let's go ahead and make a surface out of it first and just kind of see what it looks like. So I have the same grid of points. They've been moved around in the z-axis based on their proximity to these attractor curves. And then let's say I wanted to make a new surface through this. It's actually pretty simple. I'll just go to surface, go to freeform, and go to our surface from points component. And I'll go ahead and plug those points into my P, which is my grid of points. And then the other thing that this component requires to run is a number of points it has in the U direction. And I believe, so yeah, so back here is where we subdivided our surface into points. So our U output here is like the number of divisions. So I believe what we actually have is one more point than this number. And also remember, it's automatically rounding that number up to 12, because you can only divide by whole numbers. All right, I'll go ahead and, add 1. The plus 1. This will automatically create a addition component with 1, a value of 1 entered in the B input. I'll just go and plug in my U to the A input, and then that should be the correct number of U points to go into my surface there. Okay. Actually doesn't look too bad. Oops. So actually, yeah, not that cool. But so that's one technique we can do. We could also play around with just, again, putting those same points in. So if we were to just put in the points that we pulled, rather than moving them, remember those are these ones, it would give us a surface something like that. But what we can also do is we can change the distance that it's moving based on these distances. So it doesn't have to go the full distance like to the attractor point. So how would we do that? This D output is giving us the distance of each original point to its nearest attractor. So all we have to do is multiply that number by a multiplication factor. So any number between 0 and 1, is going to kind of proportionally shorten that distance. So we can kind of change basically like how much effect that's having on our the deformation of our surface. Now, the other thing I wanted to show you with this was like, how do you do this for more than one set of curves? Remember, we set this other set of curves as well. So what we can do is kind of the same procedure, just do it after our first set of moved points. I'll move this over to the right a little bit. I'm going to copy paste my pull, and then I'll also set that to a different vector. And then I can do the same thing. I can copy paste this stuff. So I'll give it a multiplication factor, and that'll be based on that distance. And then I can also, rather than moving the original set of points, I'm going to move my moved points from my previous operation there. I'll move them. Basically, I'll move them again. I'll move them twice. Then I'll go ahead and plug that in instead. And so what that does is it kind of combines the influence of these two sets of curves. And so you can see we start to have something that's kind of conforming. If I go ahead and I'm going to do a custom preview here so I can see it. Swap my viewport into rendered. Okay, so that's kind of cool. It's kind of interesting. And again, remember, so these are all being influenced by curves that are in our Rhino space. So if I were to move these around or scale them or do anything like that, it's going to actually, change like what's going on with our surface there. So we can always play around with the influence of each of these curves, even once we have the script going. And again, we can also play with the strength vectors there. And then ultimately, we could also play with, either moving them purely in the z dimension or moving them between their initial point and their nearest attractor. So another way to visualize that would be if we go down here and we wanted to make a line that goes between points, kind of like this, but use that as our movement vector. So I'll hide all this shaded here. So let's say we wanted to move all these points to their nearest attractor, like we were talking about, like what our pull component does, but we want to not move them all the way. So again, we can control the distance that they move by a factor. The easiest way to do that is probably to make a vector. So if I type in vector 2 point, so this vector 2 point will make a movement vector between the initial point of each point and the pulled location of each point. I can get a vector display to visualize that. So I'm not going to use this anymore. So there's my initial movement point. There's my vector. So that's just turning each of these pulled points into a vector, so that now we could move our point from its initial point to its pulled position. But now we can also change then the length of each of those vectors. So I'm just going to borrow this multiplier. I can and then I can plug that into an amplitude. So I'll go to vector, get an amplitude component. And so what this does is it just changes the length of a vector. Now we can use our multiplied distance value to kind of shorten that vector. And if I plug that amplitude in, you can see now we're kind of controlling how long that vector is. So how far the point moves between its initial position and its attractor. All right. And so now then we can use that as our move instead. So I'll go ahead and fix this. That's our vector. Those are our original points. And remember, then we plug that into this as well after the fact. So that starts to give us like a kind of a very different result. So that's another way of kind of distorting that set of curves based on this. I'm sorry, that surface based on this set of curves. I'll play around with these. Now the other thing that matters, I think, will be the proximity. See that changes how much one set of curves versus another kind of impacts it. All right. So yeah, so we can play around with that. And then, yeah, get all kinds of interesting results. Play around with the curves that are influencing this, and play around with their strength, how much they're moving the surface. So that's kind of a pretty, easy technique to go ahead and start playing around with the deformation of a surface based on a set of curves. Again, you can use any kinds of curves here as well. You don't have to use like repeating ones or wavy ones or anything like that. But this is kind of a simple technique for distorting a surface based on a set of curves. All right.